Types of lateral earth pressure, active earth pressure. It is undoubtedly the word active is followed by passive earth pressure, and another one is there at the pressure at rest. So someone can ask me, movement of wall with respect to backfill. The categorization has happened with this consideration, movement of wall with respect to backfill. See, sometimes you see, I have a wall here. I will show you. So this is the retaining wall, and we have backfill. This is the backfill soil. Let me say sandy soil for our convenience. In beginning, we say soil is poisonless. This is the height of the wall. Now the thing is, you are very much interested to understand what is active force. See, if the wall is moving away from the backfill, this is the backfill, I can tell you. Better I will select another sketch. Here you see movement of wall with respect to backfill. When the wall is moved away from the backfill, then the wall is, that means you just see my symbol, where I am drawing the symbol away from the backfill. When the wall is moved, moves away from the backfill, what we can ensure now, when the wall is moves away from the backfill, wall is moving away from the backfill. Now that means you see the soil, what we call backfill, the back of the wall is filled with soil. That's the meaning of backfill. So here you see the soil is exerting pressure on retaining wall. That's why the wall is moving. So that means you see it is an example of what I say, active force. This is an example of active force. So this is what I can tell you, active earth pressure. So we are designating with small pa. Now passive earth pressure. This I am writing as pp. Passive earth pressure. Now you see again we are trying to create a situation. I have a retaining wall here. You see, this is my retaining wall. So no doubt this is the height of the wall, and it has a backfill actually. It is supporting soil, neighboring soil. So the thing is, here you see this is the height of the wall. Now the wall is, in fact, wall is moving towards the backfill. Wall moving towards the backfill. Hope you understand what I'm saying. Towards the backfill. Now the wall is moving towards the soil. Now I think it is now passive. So now this is the situation we can express. We can expect now the earth pressure. In this situation we call passive earth pressure. Now this is passive earth pressure. The pressure acting on the retaining wall is now is passive earth pressure. When the wall is moving towards, I can show you once again without any dilemma. When the wall is moving towards the backfill, then we can expect passive earth pressure. So we have active earth pressure. The thing is here, you see, if you understand, sigma h dash is equal to k into sigma v dash. In fact, we are discussing about actual pressure, PA. Now I can write Ka into gamma j. Someone can ask me, sir, what is Ka? Ka is coefficient of actual pressure. Now someone can ask me, now sir, show me how to calculate PP. So can anyone ready to tell me now sigma h is equal to k into sigma v dash? What I am supposed to write here? Kp. Can anyone tell me what is Kp? Coefficient of passive pressure. So now the thing is, when the wall is moving towards the backfill, then we can expect passive. Now the third case, see when the wall is not moving anyway. Here you see I have a retaining wall. Fortunately, this is a retaining wall. It is rigidly connected with the other wall or with the other structural member. So this is the beam actually. Now, if you observe here, this is the soil actually. So now the wall is not moving anyway. In fact, you see here, the wall is not moving because the wall is rigidly connected. So the top of the wall is rigidly connected here. You see, now I can write P naught at the pressure at rest. This I am trying to write small P naught, small P naught. So now the question is, how to calculate P naught? Are you right there now? మీరు ఎవరైనా చెప్తారండి? Because P naught is a horizontal stress, K into sigma V dash. What I supposed to write now? K naught. What is K naught? Is K naught at the pressure coefficient of at the pressure coefficient of at the pressure at rest. So now you see the wall is not allowed to move. So there is no movement of wall. I can write here. Wall is no movement of wall. I can write that movement. Kadalika ledu. So wall is rigidly connected at the top. So here we are now there is no movement of wall actually. Now the pressure here is at rest at pressure. K naught. If you want force, resultant force, we have at the pressure distribution diagram. This is at the pressure distribution diagram. So I want a resultant force, thrust force. I'm not thinking now about pressure. I'm thinking about force. If you want force, you need to calculate area of the active at the pressure distribution diagram. So can anyone tell me now what I'm getting now? Ka gamma h square by 2. This is capital PA. Capital PA is the force. Small PA is the pressure. PP is equal to half. Why I'm writing off? You know that the variation is triangular. Triangular ఎందుకు ఏంటంటే ఎప్పుడు ట్రయాంగిల్ అవుతుందంటే మీకు చెప్తాను చూడండి. ఇది 0, ఇది గామా ఇంటూ హెచ్. ఇక్కడ పెరిగితే గామా ఇంటూ 1, ఇక్కడికి వెళ్తే గామా ఇంటూ 2, ఇది గామా ఇంటూ 3, గామా ఇంటూ హెచ్. So that's why the stress variation is triangular and linear means because with increase in depth, with increasing depth, vertical stress is increasing. But the fact is very clear. One thing is very clear, that is we are not just calculating vertical stress, we are calculating horizontal stress by multiplying with respect to earth pressure coefficient. If I want passive, I should multiply with AP. So now my question is how to compute passive force. Get ready now? So how to compute passive force? Are you there now? Please tell me. And also, what I am expecting from you, what is the position of the resultant, point of application of resultant from base of the wall? Get ready now? How to calculate PP now? How to calculate PP? PP is equal to half AP gamma H into H. Of base into height. Here this is, I can write without any hesitation, gamma into H. This is 0 here. I can write it as 0. This is passive earth pressure distribution diagram. Passive earth pressure distribution diagram. Now this is the pressure distribution diagram, right from top to bottom. Now what I'm expecting, PP. Are you there now? Tell me capital PP. AP gamma H square by 2. This is PP. So what is the point of application of resultant from base of the wall? H by 3. H by 3. Now this time you should speak now how to calculate capital P naught. Are you there now? This is 0 here. This is K naught gamma H. This is the height of the wall. Please tell me now how to calculate at the what I say at the pressure force. What I say active force, passive force, at rest force. So please tell me now how to calculate at rest force. Capital P naught. So can anyone tell me now how to calculate now? Because of K naught gamma H into H. So now K naught gamma H square by 2. So now the question is, what about resultant? So resultant is acting at a height H by 3 from base of